Hi again, everyone. Welcome to problem type 4, solving quadratics by factoring. So let's take a look at my test paper here. We're going to go past my beautiful graphs. Not very beautiful. I struggle with the beauty of math and showing that to you. Maybe I need to spend a whole summer just graphing quadratics over and over. Just graphing beautiful quadratics. And then I can do it like those videos where you see people do like a perfect circle on the board. I can just do perfect parabola every time. Oh, if I had three wishes from a genie, that might be one of them. Okay, so let's go. We want to solve these by factoring. Notice that these aren't functions; they're equations equal to zero. Okay, if this was f of x equals like f of x equals x squared minus 17x plus 70, then we could graph that. And this would look like, well, it would have a y-intercept way up there at 70. It's diving as it crosses the y-axis and doing something like that, okay? And then if I want to know where does it equal 0, that's saying where does it touch the x-axis? So it's finding the roots or it's finding the solutions to the equation. We call these the zeros, the roots, the solutions, or the x-intercepts. They're all different words for roots or x-intercepts. So here we go back to 0 equals x squared minus 17x plus 70. Let's find out those 2 points where x forces this function to equal 0. There's 2 different values for it in this case, I happen to know. So we want to win an x game where we multiply to 70, that c value, and we add to the b value, negative 17. It's multiplying to a positive number and adding to a negative number. Hey, I know something about negative numbers. If you have 2 negative numbers, they multiply to a positive, but they add to a negative. Factor tree of 70, okay, we could do that and we'd find negative 10 and negative 7 will do this, okay? They multiply to positive 7 and they add to minus 17. And if you struggle finding that, factor tree it and look for it. And that's okay. It's okay to struggle there. All right, so 0 equals, right, yes, x minus 7 multiplied by x minus 10. Because a is 1, we can just plop those straight into the brackets with x. And then we have to realize that if 0 equals some number multiplied by some number, then one of those numbers has to be 0. If either of those numbers are equal to 0, then that's true. It's the briefcases full of cash example. Suppose briefcases exist and that there could be cash inside those briefcases, right? But any briefcase has the same amount of cash as any other briefcase. If you have $0, that means one of two things is true. You either have 0 briefcases or the amount of cash in every briefcase is $0. In either one of those cases, you have $0. But if you have some non-zero number of briefcases with non-zero amounts of money in them, then you have some non-zero amount of money. One of those two things has to be 0 for you to have $0. So that is to say, either x minus 7 equals 0 or x minus 10 equals 0. There's no other way. There's no other way for that to be 0. In this case, we can get out our inverse operations pen. We say x minus 7 equals 0, but I want to know x. So I'm going to add 7 to both sides to make that go away. And in this case, I'm going to add 10 to both sides. And that's going to give me the two answers. X is equal to 7, circle it, or x is equal to 10, circle it. Circle your answers and say I know there, and then you can even put a little therefore there. Therefore x equals 7 or x equals 10. So this is the point 7, 0, and this is the point 10, 0. So see how the visualization helped me there too? I just visualized this parabola with its way up there y-intercept. It's going down when it crosses the y-axis, and then I can imagine it has a couple zeros maybe out there, a couple solutions. Okay, so that's how you do these. You can also look at that and just remember that this is factored form of the parabola, and you need to just read these numbers but flip the signs, and that's it. 7 and 10. Okay, now let's do a harder example. 2x squared plus 3x plus 1. A is not 1, and we can't take a out as a common factor. So we have to win this special x game of a times c, which in this case is 2 times 1, just 2, multiplies to 2 and adds to 3, just the b value. Those numbers are 2 and 1. Pretty easy x game to win, if you ask me. So let's do this in a different color just to distinguish our work. We will have 0 is equal to 2x squared. Remember that we use these numbers to break down this middle term. Plus 2x plus x. So that 3x just became 2x and 1x. Okay, we use these numbers to break apart that middle term, plus 1. And then we factor by grouping. Okay, so we're going to group the first one and take out a 2x. So 2x multiplied by x plus 1 is equal to, we can take out a factor 1 here. Oops, not equal to. We can take out a factor 1 of this last group here. We're going to divide those by 1 plus 1, okay? X plus 1. Okay, it's just a little trick there so we can see it properly that the same binomial factor came out twice. This is equal to 2x plus 1 multiplied by x plus 1. And if you said, Mr. Jennings, you always tell us to visualize these things. You didn't visualize in this case. Well, let's do it. 2x squared plus 3x plus 1. Okay, so it has a y-intercept of 1 up there. Its stretch factor is 2, so it's a little bit skinnier, and it's growing as it crosses the y-axis. It's growing like this. So if this thing has roots, it's got to turn around over there somewhere, and its roots are going to be like probably pretty close, and they're going to be negative values. So let's see. If I know that 0 is equal to 2x plus 1 times x plus 1, same cash and briefcases idea, either 2x plus 1 equals 0 or x plus 1 equals 0. Let's work with this one first, and we're going to just change to green to work with that. We're going to subtract 1 from both sides to get x is equal to negative 1. And that's one of our roots. That's that one there. Okay, negative 1 shouldn't surprise us, and we can remember you just flip the sign. Okay, but in here we can't just flip the sign and say that's also negative 1 because we're multiplying by 2x. So better to do this one algebraically. Let's here we're going to do the same thing, just in different colors here. I'm just going to go purple. Just get some purple into this problem. Minus 1 on both sides gives us 2x is equal to minus 1, and then we divide both sides by 2 because division is the opposite of multiplication, to find that x is equal to negative 1/2. Or if you prefer, negative 0.5. It's exactly the same thing, and that's this root here. Okay, so circle them, pion and pion. And then maybe rewrite it because we got a little messy. Therefore, x equals negative 0.5 or x equals negative 1. Circle that statement. Cool. All right. I think it's cool. Maybe you don't, but yeah, with practice, maybe you find it cool too. All right. Bye for now, everyone. If you have any questions, hit me up with an email, and thank you for showing up for your learning.